Welcome to today's episode of the California GACCs Weather Terms video series. Our topic for today is a classic coastal California staple, the marine layer. This is a topic we refer to a lot during the spring and summer months and is the reason for the dreary season along the coastline that we typically call May gray and June gloom. In this video, we will cover what the marine layer is, how and why it forms, and how it influences weather conditions. The marine layer is a dense and stable layer of cool, moist air that is formed by warm air flowing over the cool ocean. The cold water of the Pacific Ocean cools and moistens the warmer air directly above it to create a cool and moist air mass near the surface. As a result of the lower layers of air being cooled from the bottom, much warmer air is kept at higher levels. Temperature warming with height is called a temperature inversion, which caps the marine layer below. Formation of the marine layer is most common during the spring and early summer when there is a large contrast in temperature between the deserts and the ocean surface. Water temperatures tend to warm during the summer, so there is less of a contrast in temperature to the land, but the marine layer can still be prevalent during the summer under the right conditions. Low-level clouds are likely to form within the marine layer due to the cool and moist conditions. However, this is not always the case. Even though the marine layer is formed over the ocean, the persistent sea breeze often moves it over coastal California and at times even up the coastal slopes depending on its depth. We typically describe the state of the marine layer in terms of its depth to determine the potential level of impacts. The depth of the marine layer is simply the depth of the cool, moist layer of air beneath the inversion, or in other words, the height of the base of the inversion. The marine layer depth is dependent on numerous factors, including large-scale weather patterns and low-level wind flow. Let's start by looking at how the marine layer is affected by a strong area of high pressure overhead. Like we discussed in a previous video, air descends to the surface and warms under high pressure. As such, this will squish the marine layer, making it become shallower as well as strengthening the inversion. Sometimes if high pressure is sufficiently strong, the marine layer is eliminated and the inversion becomes surface-based. When the marine layer is squished, any low clouds are usually confined to the coastline and typically clear by early to mid-morning with daytime heating. There is a caveat here though. Under a very strong inversion, clouds can strongly latch to the beach areas and struggle to clear at all. In shallow marine layer regimes, cool air is limited to the coastline. In inland areas, even just a few miles from shore, temperatures can soar. Fire weather concerns also tend to be greater due to more widespread warm temperatures, lower humidity, and less expansive zone of good overnight recoveries. When an area of low pressure approaches, the lift associated with it can deepen the marine layer and thus bring a more expansive blanket of low clouds. When the marine layer significantly deepens, low clouds will surge into the coastal valleys and possibly even up the lower coastal slopes. Clouds are much slower to clear in this regime, and oftentimes the coastal areas will remain cloudy all day. One thing to note, however, is if a strong and cold area of low pressure is overhead, the cold air aloft can break the inversion and thus eliminate the marine layer, and cloud cover may be more disorganized. In a deep marine layer environment, cooler air expands far more inland and warmer temperatures are limited to interior areas, typically to the east of the mountains. Fire weather concerns tend to be lessened due to a more expansive area of cooler temperatures and higher humidities and overnight recoveries. That's it for today's episode of California GACCs Weather Terms. We hope you now have a greater understanding of the marine layer and why it has a large presence over California. Thanks for watching, and we'll see you in the next one.